a comprehensive builder's manual for a hybrid Xrpl Songbird tournament. Fighting game. Part 1. Foundational architecture. A dual-chain strategy for competitive gaming, Chapter 1. The architectural vision, a symbiotic dual-ledger approach. The development of a sophisticated on-chain competitive game necessitates an architectural design that is both robust and specialized. The core philosophy of this project is to leverage a best-of-breed blockchain strategy, assigning specific critical functions to the ledger best optimized for them. This manual outlines a symbiotic dual-ledger architecture that strategically separates the asset and AMP, value layer, which will reside on the XRP ledger, Xrpl, from the logic and AMP, computation layer, which will be executed on the Songbird network. This separation of concerns is a foundational principle that extends beyond software design into blockchain architecture, providing enhanced performance, security, and long-term viability. The asset in AMP, value layer, XRP ledger, Xrpl. The XRP ledger is designated as the canonical layer for all in-game assets. Its architecture is exceptionally well suited for the high-frequency, low-cost operations required for asset management in a gaming ecosystem. Role of Xrpl. The Xrpl will serve as the definitive source of truth for ownership of all fungible and non-fungible tokens within the game. This includes the issuance, custody, and transfer of the primary prize tokens, MB589 and MG589, as well as the unique character and item NFTs that players will own and use in battle. The process for creating these fungible tokens is native to the ledger, requiring no complex smart contracts, which simplifies development and reduces attack surfaces. Two players will interact with the Xrpl to establish trust lines, a prerequisite for holding issued currencies, and to receive their winnings directly into their self-custody wallets. 3 key advantages. The Xrpl's primary advantage is its performance and cost-effectiveness. With transaction finality occurring in 3 to 5 seconds, and fees that are fractions of a cent, it is an ideal environment for managing the high volume of microtransactions inherent in a gaming economy, such as prize distributions or marketplace trades. Furthermore, the Xrpl features a built-in decentralized exchange, DEX, which can provide immediate on-ledger liquidity for the MB589 and MG589 tokens, allowing winners to trade their prizes for XRP or other assets without relying on centralized exchanges. The logic in AMP, computation layer, Songbird network. While the Xrpl excels at asset management, the complex stateful logic required for a tournament system, including registration, bracket management, prize escrow, and dispute resolution, demands a more expressive computational environment. The Songbird network, Flare's Canary network, is selected for this role due to its full compatibility with the Ethereum Virtual Machine, EVM. 6. Role of Songbird. Songbird will function as the game's decentralized backend, hosting the Solidity smart contracts that govern the entire tournament lifecycle. These contracts will manage player registration, automatically generate tournament brackets, hold entry fees in escrow, receive and verify match outcomes from the off-chain game server, and trigger the final prize distribution. As an EVM-compatible chain, it allows the project to leverage the world's largest ecosystem of developer tools, Hardhat, Truffle, security standards, OpenZeppelin, and battle-tested code patterns, significantly accelerating development and enhancing security. Key advantages. Songbird's EVM compatibility is its defining feature for this project. It enables the deployment of complex, Turing-complete logic that is not natively supported on the Xrpl. Furthermore, its position within the Flare ecosystem provides access to enshrined protocols like the Flare Time Series Oracle, FTSO, and the Flare Data Connector, FDC, which are crucial for secure cross-chain communication, a cornerstone of this hybrid architecture. Rationale for a dual-chain architecture. A frequent consideration in such projects is whether a single blockchain, such as an Xrpl sidechain with EVM compatibility, could serve both purposes. While technically feasible, the dual-chain approach is a deliberate strategic choice designed to optimize for both performance and risk mitigation. By leveraging the Xrpl mainnet, the game's assets tap into the deepest liquidity and the largest, most established user base within that ecosystem. This is critical for the value and utility of the prize tokens and NFTs. Simultaneously, offloading the complex and potentially gas-intensive computational logic to a dedicated smart contract platform like Songbird prevents the game's operations from being constrained by the Xrpl's more specialized design. This architectural separation provides significant resilience. For instance, should the Songbird network experience a period of high gas fees or congestion, the core player assets on the Xrpl remain secure, liquid, and transferable. Conversely, any issue on the Xrpl would not compromise the integrity of the in-progress tournament logic on Songbird, which could be designed to pause and resume gracefully. This design is not merely a technical implementation, it is a strategic framework to de-risk the project by preventing a single point of platform failure and ensuring each component operates in its most optimal environment. Chapter 2. System Component Overview. The 5 Pillars of the Architecture. The game's architecture is composed of 5 distinct but interconnected pillars. Each component has a clearly defined role, and their interactions are orchestrated to create a seamless experience that spans from real-time gameplay to decentralized asset ownership. A high-level diagram would illustrate the flow of information and value between these pillars. The player's client communicates inputs to the game server, which in turn reports outcomes to the Songbird logic layer. The logic layer interacts with the Xrpl asset layer via a cross-chain bridge, and the player client manages wallet connections to both chains to authorize transactions. Player client, game frontend. This is the user's portal to the game world, developed using a cross-platform engine like Unity. Its primary responsibilities are rendering the 2.5D characters and environments, capturing player inputs, joystick movements, button presses, and communicating these actions to the authoritative game server in real time. Crucially, it also houses the wallet integration layer, which interfaces with both the Zaman SDK for Xrpl transactions and an EVM-compatible wallet library, e.g., ethers.js for Songbird interactions. Authoritative game server. This is the off-chain centralized brain that ensures fair and cheat-free real-time gameplay. It receives a stream of inputs from all connected player clients, processes them through a deterministic game simulation, and broadcasts the resulting game state back to the clients. Because the server is the sole arbiter of what happens in a match, e.g., registering a hit, calculating damage, determining a knockout, it prevents client-side manipulation. Its final critical role is to cryptographically sign the definitive match outcome and submit it to the Songbird smart contracts for on-chain settlement. XRP Ledger, Asset Layer. As established, the Xrpl is the system's decentralized bank. It is the immutable ledger where all items of value are issued and stored. This includes the fungible prize tokens, MB589, MG589, issued as IOUs, and the unique meme warrior characters represented as NFTs under the XLS20 standard. All economic finality, the actual payment of prizes to the winners, occurs on this layer. Songbird Network, Logic Layer. Songbird acts as the tournament organizer and digital referee. Its EVM-compatible smart contracts are the immutable rulebook for the competition. These contracts handle the entire administrative lifecycle of a tournament. They accept registrations, manage the progression of the tournament bracket, hold entry fees in a secure escrow, and execute the automated distribution of prizes based on the server-attested match outcomes. 10 Cross-Chain Bridge, F-Assets Protocol. The bridge is the vital communication link between the logic on Songbird and the value on Xrpl. This architecture will employ Flare's Facets Protocol, a trust-minimized system that allows assets from a non-smart contract chain, like Xrpl, to be represented on Flare Songbird. For this game, it will be used to wrap MB589's MG589 tokens from the Xrpl onto Songbird, allowing them to be managed by the Match Escrow smart contract. At the end of the tournament, the process is reversed to pay the winners with the real tokens on the Xrpl. The following table provides a clear data-driven justification for this dual-chain architecture, making the case for this design to all project stakeholders, from developers to investors. It transforms a complex architectural decision into an easily digestible business case, demonstrating that the chosen structure is a carefully considered optimization of available technologies. Table 1. Technology Stack Analysis Feature XRP Ledger, XRPL. Songbird Network, Primary Role Asset ANAMP, Value Layer, Issuance, Custody, and Transfer of all tokens and NFTs. Logic ANAMP, Computation Layer, Execution of Tournament and Escrow Smart Contracts. Consensus Mechanism, Federated Consensus, Unique Node Lists, Snowman++, Avalanche Consensus, with Proof of Stake, POS, Sybil Resistance. Avg Transaction Fee. Tian. On-chain minting and linking. The final step is to execute an NF token mint transaction on the XRPL. The URI of the metadata JSON file, itself stored on IPFS, is embedded into the URI field of the NF token object during this transaction. This creates an unbreakable and publicly verifiable chain of provenance. The on-ledger NF token points to an IPFS URI for its metadata. The metadata file at that URI contains the character's attributes and points to other IPFS URIs for the actual game assets, images, models, etc. This pipeline ensures that the ownership recorded on the XRPL corresponds to a specific immutable set of digital assets, free from the risk of broken links or centralized server failure. Authenticity and verification. To combat forgeries, where a malicious actor might mint an NFT with metadata pointing to another project's assets, a verification system is necessary. Sologenic, a prominent XRPL marketplace, has developed a method for embedding a signed JSON Web Token, JWT, within the memo field of the NF token mint transaction. This JWT, signed by the project's official private key, contains the authentic NF token ID. A verification tool can then check that the JWT in the memo is valid and that the NF token ID within it matches the ID of the NFT being inspected. This provides a forgery-proof way for users and marketplaces to confirm the authenticity of a character NFT. Chapter 5. Player Onboarding and AMP. Wallet Integration. Zaman XUM. The primary gateway for players to interact with their XRPL-based assets is the Zaman, formerly XUMM, wallet. A seamless and secure integration with Zaman is therefore paramount for the game's user experience. The architecture must adhere to a non-custodial principle. The game and its servers must never have access to or store a player's private keys. All XRPL transactions must be signed by the user through their own wallet. Back-end SDK integration for payload signing. The recommended method for integration is to use the Zaman SDK on the game's back-end server. This approach, known as the payload or sign request flow, provides a secure and user-friendly experience. Payload creation. When a player needs to perform an on-chain action, e.g., set a trust line, create an NFT offer, the game client sends a request to its own back-end server. The back-end server, using its API keys for the XUM developer console, constructs the raw XRPL transaction JSON. It then uses the Zaman SDK to create a payload containing this transaction definition. Sign request delivery. The Zaman API returns a unique payload UUID and a QR code URL. The backend sends this information back to the game client. User approval. The game client displays the QR code for the user to scan with their Zaman mobile app, or it can trigger a push notification directly to the user's device. The Zaman app presents a clear, human-readable summary of the transaction, e.g., set trust for MB589, create offer to sell character number 123. The user reviews the details and approves or rejects the transaction using their passcode or biometrics. Transaction. Submission. Upon approval, the Zaman app signs the transaction with the user's private key and submits it directly to the XRPL. The game's backend can subscribe to a webhook or poll the Zaman API with the payload UUID to get the final status of the transaction, e.g., success, failure, transaction hash. This flow is highly secure because the player's secret keys never leave their device. The game server only defines the transaction. The user has the final authority to sign and submit it. designing the multi-wallet user experience. The most significant UX hurdle in this project is the requirement for players to manage two distinct blockchain identities, an Xrpl account for assets and an EVM account on Songbird for game logic. Forcing a user to manually switch between Xrpl for one action and MetaMask for another will create a confusing and frustrating experience that could severely hinder adoption. The architectural solution is to abstract this complexity away from the player through a unified wallet manager within the game client. This manager must be designed to handle the connection states for both wallets simultaneously. When a player initiates the game, the onboarding flow should prompt them to connect both their Xrpl wallet and their preferred EVM wallet, e.g. MetaMask, via a browser extension or Wallet Connect for mobile wallets. The unified wallet manager will then store the public addresses and connection statuses for both chains. When a game action requires a signature, the manager's logic will determine which chain is necessary. For example, action. Player clicks, register for tournament. Logic. The manager knows this involves paying an entry fee to a Songbird smart contract. Result. It triggers a signing prompt via the connected EVM wallet provider, e.g. Ethers.es, causing a MetaMask pop-up to appear. 2. Action. Player wins the tournament and clicks Claim Prize. Logic. The manager knows this involves receiving real MB589 tokens on the Xrpl, which first requires a trust line. Result. It triggers a trust set sign request via the Xrpl SDK, prompting the user to approve the transaction in their Xrpl app. By centralizing this routing logic, the player is presented with the correct, context-aware prompt every time, without needing to understand the underlying dual-chain architecture. This abstraction is not merely a convenience, it is a mission-critical component for making the game accessible to a broader audience. Part 3. The Logic and AMP. Execution Layer. Smart Contracts on Songbird. The Songbird network serves as the decentralized computational core of the tournament system. Its EVM compatibility allows for the deployment of robust and complex smart contracts written in Solidity, which will manage the entire lifecycle of each tournament event. The on-chain logic will be modularized into several distinct contracts, each with a specific responsibility, following security best practices to protect player funds and ensure the integrity of the competition.